Hello students, good morning to all of you. Am I audible?
Good morning, ma'am.
Yeah, what happened? These are students. लीव क्यों कर जा रहे? Age. How was the quiz? Yes?
Good.
Because every is tough for itchy. Hmm?
Okay, not that tough, not that easy.
Okay, good. In chapter 1, we have discussed about planarity of the graph, right? Planar graph, plane graph. So in this chapter, we'll discuss about all these. So what do you understand by plane graph?
Ma'am,
Hmm?
I have a doubt from chapter 5 to find the chromatic number of a complex graph using subgraph method.
Okay.
Can you explain it?
By edge contraction method or what?
No, ma'am, by that relation method that chromatic number is less than equal to proper curling.
Chromatic number. Okay. I thought chromatic polynomial. So if you are able to okay, any graph G is K colorable, then you can only say that this chromatic number will be less than equal to K. Clear?
Yes, ma'am.
And if you show there is some subgraph about this subgraph, you already know the chromatic number. For example, as it's X is non-subgraph, suppose K and type, right? Or star type, or P and type, CN. Okay. If this is the subgraph of G, then what can you say about chromatic number of G? It will be greater than equal to chromatic number of H. Clear?
Yes, ma'am.
So chromatic number of H and chromatic number of G are related by this one. Okay. So if you know that chromatic number of H is also K, then it will be greater than equal to K. Clear?
Yes,
From
ma'am.
here, you can say this is exactly equal to K. So two things, one is K colorable, another is find some subgraph about which you already know with chromatic number. That's it.
Ma'am, in that example, there was a C5 from that
C5.
Peterson graph.
C5 with
And you have taken three coloring. Can we take five proper coloring?
five proper coloring, yes, you can do, but there exists three coloring as well as two coloring. Sorry, three coloring, not two. Three coloring, four coloring, and five coloring.
Okay,
Clear?
so range will become large, so we cannot decide which one.
Yes, we cannot decide. If at all, if you are able to find some K minus one coloring, then you should take that, right?
Yes, ma'am. Okay, ma'am. I got
So
it.
in small graphs, whenever EG graph, you already know that means if you are able to decide this is the minimum coloring, then that will be the corresponding number is chromatic number. Okay. And if some complicated is there, you can use this formula. Okay, this method. No
Yes,
problem.
ma'am.
For example, if you say some graph is not bipartite, if bipartite, then chromatic number have to be 2, right? If it is not bipartite, then have to be greater than equal to 3. And if you are also able to show that there exists three coloring as well, so you can say chromatic number is at most 3, and we have
Yes, ma'am.
already given the statement that it is not bipartite. That's why it is greater than strictly greater than 2, that is greater than equal to 3. So its chromatic number will be exactly equal to 3. Clear?
Yes, ma'am.
Okay. Yeah, plain graph, planar graph. Yeah, before that, क्विज में कैसे क्वेश्चन आए थे ये तो बताओ. How many
Ma'am,
questions? 30 question.
yes, ma'am. 30 question.
40 or 30?
30. 30.
30.
Please.
Okay. Okay. 30 questions, 30 minutes.
Yes, ma'am.
Solved all the questions?
Yes, ma'am.
Okay. So do you remember some question? ये सब भूल गए.
हम क्वेश्चन देखने से याद है.
ओके, टॉपिक बताओ. क्वेश्चन याद है तो क्वेश्चन बताओ, अदरवाइज टॉपिक बताओ किससे.
मैम मेरे सेट में क्वेश्चन था, उसमें ट्री दिया हुआ था और बोला था कि उसके सारे वर्टेक्स जो हैं 4 डिग्री के हैं तो 6 डिग्री के हैं, और नंबर ऑफ वर्टिसेस दे दिया था उसमें. तो बोला था कि कितने नंबर जो हैं 4 हैं, कितने 6, कितने 4 हैं वो बताओ. तो ये क्वेश्चन था.
Okay, so you need to find the degree corresponding to that, right?
No, ma'am. Number of vertices having 4 degree. What?
4 degree. So
Vertex.
you can use the degree sum formula, right?
Yes, ma'am.
Suppose order is n, or in particular, suppose 10. There are 3 vertices with 3 degree, 5 vertices with some other degree given, and find the remaining degree. You can easily do that, right?
Yes, ma'am. Using the letter code.
Yes. By using the degree sum formula. What else? Yes?
Question.
Bipolar graph related with questions.
Sorry, you're not audible clearly.
Ashutosh, you speak, then I will follow.
Okay.
Not you speak.
I was saying bipartite graph related with questions.
On the basis of
Regular graph.
bipartite graph.
Yes, ma'am.
Which type of question?
And K regular graph cycle and odd cycle है या फिर
Yes, with this we have done the same number of
Yes,
types. Yes. Okay.
and then graphic sequence के ऊपर भी एक क्वेश्चन था, मतलब इतना डिटेल में याद नहीं, बट इट्स लाइक हल्का हल्का.
Yeah. ग्राफ ड्रॉ करना था, ड्रॉ तो करना ही नहीं था. ग्राफ दिए हुए थे ऑप्शन में.
ऑप्शन दे रखे थे, लाइक सीक्वेंस दे रखे थे. वी हैव टू पिक द
Okay, which
ऑप्शन.
one of the following is graphic or not?
Yes, ma'am.
Okay. Okay, from chapter 3, it was up to 3.1, right? And midsem कब है? 16th को और 21st?
इनसे शुरू है.
IGT 21st को. Okay. And syllabus आ गया उसके लिए? There is staying up to 3 chapter 3. तो तब तक तो हमारा 7th chapter भी complete हो जाएगा. फिर बाद में क्या करेंगे?
Revision.
Revision, it will be very, very boring again and again. Uh, okay,
Questions.
we'll revise it. Before midsum, we can revise it. First, I can complete this 6.1. Okay.
Yes.
Uh, I'm not sure what they are saying. Up to 3 day or 5 chapter day. It's just going discussing. So I'll tell you if decides. Okay. Okay, come back to the plane graph. Define it. What do you understand by plane graph?
Where edges do not cross. Like no crossing is there.
So this is a graph in which is drawn in such a way that edges do not cross. This graph is plane, right?
This one.
This one is also plane. What about this one?
I'm not playing.
This
Not
is
plane.
not plane. Clear? Their edges are crossing. These two edges cross each other. What do you understand by planar graph? So plane
It
will
can.
be just wait a minute. Plane is just depend on the how it is drawn, already drawn, right?
Yes,
Yeah.
ma'am.
Now tell me planar.
Where
Well,
it can be drawn as a plane graph. Then it
it
is
can
planar. If
be
it's
drawn as a plane graph. So all these are planar. This is
yes.
already a plane graph, already a plane graph, so planar. So every plane, obviously, it is planar. Okay, but every planar graph we cannot say. For example, this part of K4 is not plane but planar, right? This you can draw like this graph, yeah, this one. Clear? Okay, there is some example started. It is asking that three enemies ABC living side by side have path to three utilities connection: gas, water, electricity. In order to avoid confrontation, they don't want to face anyone, so that they don't want to cross any path. Okay, any of these paths. Can it be done? In graph theory, this question can be asked first. Draw the graph corresponding to this situation, and then it can be asked whether this graph corresponding the graph is planar or not. Clear? So three person ABC we have, and here utility: gas, water, electricity. Okay, we want all these. Same for this one, and same for this one. Okay. Now this is the corresponding graph to this situation, and the question is they don't want to confront each other. Okay, that's why they don't want these paths to cross. So can it be done? Can we redraw this graph such as no two edges cross each other? This graph is which graph? K33. Clear? Got it?
Yes, yes, ma'am.
So is K33 planar?
No, ma'am.
No. So cannot be done. इनका झगड़ा होना तो बाकी श्योर है, right? Okay, this is the graph and it cannot be drawn in as a plane graph. That's why it is not a planar, and this cannot be solved, this problem. They have to face. Okay? They cannot avoid confrontation. Yeah, this is the definition of this planar graph. It can be drawn as a plane, now two edges cross each other. Plane. This plane part is also known as planar embedding. Okay? Planar embedding. Clear? Every planar embedding, or you can just say plane graph is planar, but not this one. Okay. Can I ask you one thing? C4 or CN. CN is plane graph or planar graph?
Both, ma'am.
Both.
Sure.
Yes, ma'am.
Okay. I'm just drawing C4. Now tell me.
It's planar.
Planar.
It's planar, not plane. So how can you say this? This CN is both. See, plane part will depend on how it is already drawn. Okay, it is already drawn. By looking at that figure only we can decide. But planar is, it can be drawn. You can redraw this graph. Okay, plane you cannot redraw. Okay, so CN is planar graph. That's why every planar graph can be redrawn as plane graph. That's why we will be talking about only planar graph. Okay, because this we can redraw it, and we know that we can redraw like this, and that is same as this one, right? Means isomorphic. Okay. Now K23, planar or not? K23.
Yes, ma'am. Planar.
K24.
No, ma'am.
Sure. Just try it. K22 is this one, right? K23. This one, this one, this one. This one, then this. You can redraw like this, or what do? This vertex over here, this one. Okay? These two vertices are independent, are in same set. Okay, so this is your K23. What about K24? In the same way you can redraw it, right? Star, planar, K1n, or n minus 1 you can just say. K2n, planar, right? Kmn or Kr comma S, this is planar for which R and S, or you can say a graph which is not planar, that is known as non-planar. Okay, for which R and S it will be non-planar. For which R and S it will be non-planar.
Ma'am, for R less than equal 1 and S greater than equal 2.
I'm just saying non-planar.
And R greater than equal to 3. And S
R greater than equal to
3.
3 and S
S greater than equal to.
yes, both the graph at a time, if we have these are greater than equal to 3. If one is less than 3, then it is planar, right? both the R and S, okay, both numbers R and S greater than equal to 3, it is non-planar. Clear? In any graph, if H is your planar graph, H is planar I'm giving you, and this is the subgraph of any other graph G. What can you say about G? H is planar. What can you say about G?
No, ma'am.
We cannot say.
Can't say, right? If G is planar, then H will be
Planar.
always planar, right? Because the bigger part can be drawn as a plane graph. That's why small part is okay. That if G is if for a subgraph, you can just say if H is the subgraph of G, this is given thing. G is planar implies then we can say H is planar. Clear? Okay. What about if I say G is non-planar? Then H, if G is non-planar,
H can be or cannot be planar.
H can be a planar, right? And if H is
Yeah.
non-planar,
G cannot be a planar.
G cannot be planar or non-planar?
Non-planar.
Non-planar. Sure.
Wait, ma'am.
The smaller part, if you are not able to draw it, then how the bigger part? Okay. This is also non-planar. Clear? स्मॉलर पार्ट में एजेस क्रॉस कर रही है तो बिगर पार्ट में तो करेंगी राइट ओके so these two things you can remember it whenever H is subgraph the bigger one is planar the smaller will be always planar and the smaller one is non-planar then the bigger one will be always non-planar understood what about complete graph PN is planar PN planar CN planar what about complete K1n minus 1 or K1n this is also planar KRS whenever R and S both at a time this greater than equal to 3 this is non-planar otherwise it is planar yeah what else K2n or in general it can be also Kn1n this is planar what about Petersen graph and complete graph
Ma'am, complete graph up to K4 it is planar.
yes up to K4 it is planar so for n less than equal to 4 it is planar what about QK cube in K dimension Q2 starts with uh,
It is
Q1
planar.
K2 only that is planar Q2 that is square C4 that is also planar Q3 what about Q3 planar Q3 this is your Q1 this
Yes,
is
ma'am.
your
Planar.
Q2
Q type.
and this is your ah, anyways yeah this is your Q3 Is it planar?
No, ma'am.
No. Sure. Can you redraw this such as no two edges cross each other? Try to shrink this part. Try to draw small this part of this part inside. You can just say bigger one is this one, and there is one other. Now there is a
Planar.
plane part of this. So this is also planar. So QK is planar for 1, 2, 3. Clear? What about Peterson graph? Peterson graph.
I'm not.
Not planar. What I'm just drawing. 5 vertices. This one, non-planar. We will
Yes,
prove it. Not now. This you cannot draw as a plane. Okay? K4, the plane part of K4 is drawn as this one. Okay? What about K6? K6,
non-planar.
non-planar. And if I draw this graph, non-planar, right?
Yes, ma'am.
Yes, ma'am.
Because K5 is non-planar and K5 is present over here, right? Bigger is also non-planar. Similarly, K34, K6, K5, K33, these are non-planar. Okay? Now, whenever you are drawing this planar graph as a plane, okay, as a planar embedding, or you can just say plane part, this has some face, okay, faces, vertices, 4 vertices it has. These are edges, you already know, and these regions are known as its faces. Okay, so X is your unbounded region, Y, Z, W are bounded inside region. Clear? Okay. Don't try to count the faces over here, otherwise you will miscount it. Okay. Overcount these faces. Always count the faces in plane part of planar graph. Okay. Yeah. Why this K5 and K33 cannot be drawn as a plane part? Cannot be drawn without edge crossing. Yes. By looking at the graph only, you can say it. Or in any graph, if suppose K6, K33 you have, K33, I'm just trying to draw K33. Is this K33? This one, independent of this vertex, independent of this vertex. Okay? So this is your K33. Why this is? We cannot draw this as a non-planar, plane part. Here we have, except this C6 part, outside part, how many you can just say chords we have? 3 chords, right? And these are alternative chords. This endpoint, this is the endpoint of this chord. Second alternative, third chord, right? So if in any cycle, if any cycle is there, you have alternative chords. So one can be drawn inside, and other if it crosses this chord, or other edge if it is crossing this edge, then you can draw outside. Because it was having alternating vertex, that's why we have drawn like this. So if at all there exists again a third chord that alternates these one, that cannot be drawn as a plain part, not inside, not outside, right? It will always cross either of these. Okay. So if C is the spanning cycle means C6 we are taking over here. C6 is the spanning cycle of K33. This outer part you can see. This can be drawn without crossing. Obviously, we can draw this Cn part in case of this one C6 part. Okay. And two chords, if we remove these two chords, we can easily draw this one inside and this one outside. Okay, this one we have drawn outside to make it plainer. What about this one? The third chord I cannot draw inside, right? Because this crosses this edge, right? And I cannot draw outside as well because it is crossing outside edge. Okay. So two chords in C conflict. They will cross if their endpoints on C are alternative order. They are alternative chords, right? And these can be drawn as one inside, one outside. But about third, we cannot draw, right? So K33, I have already drawn this part. And K5, also we have how many chords which are alternative chord? 5, right? 1, 2, 3, 4, 5. Okay? All inside chord. So what you have? In case 3, there is this 6 cycle outside, but 3 alternating chords are there. These are pairwise conflicting chords. That is, if you take any 2 chords at a time, these are conflicting. Okay. So you can draw out of these 3 only 2 chords, is that it forms the planar graph, not third. But for K33 you need to show all the chords, right? That's why it is not possible. And similarly, in case of K5, there are 5 chords inside this one. These are conflicting or crossing each other, right? So that's why we are not able to draw this. Example, in case of K33, I have already shown this how to be if you are trying to draw inside, this how to cross this one, or if you are trying to draw outside, it how to cross this one. Okay. So in all the possible ways, there is some edge which cross the other edges, right? In the similar way, here K5 minus E, this is your planar graph, but this edge creating some problem, right? We cannot draw inside, we cannot draw outside. Clear? And outside which this part, this C5. You cannot draw inside C5, you cannot draw outside. If we draw outside, it is crossing this edge, so non-planar. If we draw inside, it's crossing this edge, non-planar. So by the definition, We are not able to draw this. That's why it is your non-planar graph. In any graph containing a non-planar graph as a subgraph, that will be non-planar. So if you find some graph G where K33, either K33 is there or K5 is present as a subgraph, then you can directly say G is your non-planar graph because it has subgraph K33 or K5. Okay, clear? Yes.
Yes, ma'am.
Next is your dual graph. It is denoted by G star. If G is the graph E1, for this one we can draw the dual graph of this one. Okay, denoted by G star. And how it will be different from this one? Dual graph, for a plane graph we can draw it. Okay, every graph, every planar graph can be drawn as a plane graph. Okay, so first you will draw every planar graph as a plane graph, and only then you will be able to draw this dual graph. Okay, clear? So G star, here we have n. In G we have n is the order, m is the number of edges, and f is your number of faces. These faces are regions given by region, right? I gave you that example, K4. Or in C3 you can just say how many region it is dividing. It is dividing the complete plane, this R2 plane, this one R2 plane, in two regions. One is inside one, okay, X, one is outside. Outside is unbounded, inside is bounded. So these are its spaces. Clear? Okay,
Yes, ma'am.
these are edges, vertices. So N, M, and F. Number of F denotes the number of faces, M denotes the number of edges, N denotes the number of vertices. Corresponding to this one, there will be N star, M star, and F star. Clear? So while drawing G star, these faces will become the vertices. Okay. So of a dual for a plane graph will be again a plane graph. Okay, dual of a plane is again a plane graph whose vertices correspond to the faces of G. So N star will be equal to F. Okay, vertices corresponding to this G star. So if G is this one, G star will contain two vertices. This is your X corresponding to X region, and this is your Y corresponding to Y region. So this faces will become the
Vertices.
vertices. Okay, that's why order of dual graph will be equal to number of faces in the G. Okay, and the edge set is defined by the edge set of this one corresponding to whenever E is any edge in G, is an edge in G that connects, or you can just say there is some edge which has X and Y, X region on one side and Y region on another side. Okay, X face, Y face. So in the dual, these faces are becoming vertices, and whenever this scene is happening, then there is an edge. Means these are adjacent. Okay, then E star will be X, Y. X is corresponding to face X, and Y is corresponding to face Y. Clear? Okay, and you will always notice M will become M star. So there is M star that will be equal to M, and there will be F star, again the number of faces. Number of faces will depend. So tell me the dual of this graph, or
It will have multiple edges.
yes,
But it will have multiple edges.
it
Three
will
multiple.
have multiple edges. So X, Y, whenever this is an edge, they are adjacent, right? So E1, E2, E3. So corresponding to E1, because E1 is has X over here, Y over here, or you can just say even separates these two regions. So here it will connect, right? Corresponding to E2, here X, here Y. Again, this one. Here corresponding to E3, again one more region. One more edge.
H.
Okay, because inside it is X and outside it is Y. How many region? Here again, how many faces or region? 3. Here it was 2. Here it is 3. Okay, number of edges are same, you can see. Okay,
Ma'am, ma'am, faces are 2 and region are 3.
faces are 2. How? Faces and region are we are just saying same, no?
Okay, ma'am.
Vertices are 2. These faces become vertices. Okay, and corresponding to each edge, you already know that there will be edge. Okay, so M will be again, M star will be again equal to M, and there will be F star that can change. Okay, so here region number 1 or phase number 1, phase number 2, these are bounded, and unbounded is outside, region number 3. Clear? This is again a plane graph. What about trivial graph? K star, K1 star,
Ma'am, only one reason.
only one vertex, right? Same. What about K2? How many faces it has, or how many regions it is dividing the plane?
Ma'am, only one reason.
One, that is unbounded, right? If the graph does not have any cycle, there is no bounded region, right? Here it was cycle, that's why bounded. Here also we had some cycle, that's why bounded. But here no cycle, so unbounded region. Okay, so you can take this as R region or phase R. Yeah, tell me the K2 star. This is your K2, K2 star. There will be one vertex, okay,
Yes, ma'am.
corresponding to R.
Ma'am, it
Yeah,
will have loop.
it will have a loop. Clear?
Okay.
There is some S and there is R, there is R. So it will connect it. How many regions now? 2 regions, right? Region number 1 or phase number 1, phase number 2. Clear? So you can see the number of vertices become the number of faces over here, and the number of faces over here become the number of vertices. Clear? Edges remaining same. Okay?
Ma'am, I have a doubt.
Yes, tell me.
In above example, in K4 you have taken 3 faces. Then why you have not taken 4 faces in above example?
K4, where?
I mean this one,
4.
this one.
4. 1, 2, 3, 4.
Okay, ma'am. Ma'am,
3 bounded.
I thought X represent the graph. That's
No, no, no. This is K4 only. So this is unbounded region and these are bounded. Okay.
yes, ma'am.
Yeah, tell me the dual of K4. So this is the dual of K2, dual of, this is dual represents. So the graph with n is equal to 2, m is equal to 1, and number of faces that represents F, that is 1, phase X. Here, m star will be again equal to m, that is 1. N star, number of faces over here will become number of vertices, and number of vertices over here becomes the number of faces. So you can note it in G and G star, vertices, number of vertices, or you can just say vertices become faces and faces become vertices. Clear? and
Yes,
hence it will be n star will be f, and f star will be equal to n, and m star will become m only. Okay. Yeah, for K3, sorry, P3, not K3. This is your P3. How many region? Only one?
yes, ma'am, only one.
So
Ma'am,
it
a
will
doubt.
be, yes, tell me.
Ma'am, when we are doing the dual graph, we have to make the dual graph planar, means plane graph.
Plain, yes, plain.
Ma'am, then
Only in case of plain graph, plain part you can know about the number of faces, number of regions.
okay, ma'am.
Yes, tell me.
Ma'am, you were telling about K4. So K4 will have the exact same. Means the K4 will be same as K star graph.
K for star. So let's look at this. Yeah, four vertices will be there, and number of, yeah, yes. So here four regions corresponding. K4 star will be also having four vertices. Okay. So let me take X, Y, Z, and W. So in this place, X, Y, Z, and W. Okay. Now this edge corresponding to this edge, this one Y and W. Y and W at the
Ma'am,
center.
one. Yes, ma'am.
One edge, Z and W, W over here, W over here, right? Z and W at the
Ma'am,
center,
one.
and X and W at the center, and because this is adjacent, this is adjacent, this is, so X2 Y, X2 Z, and Z2 Y. So this is again your K4. Understood?
Yes, ma'am.
So K4 star will be this one. Again,
Uh,
same as K4.
Ma'am, I was asking that, see, K4 star graph, the edges are crossing, so it's not a plane graph. So we can draw the dual graph as a plane, which is not
Yes,
necessary to
you
be a
can
plane.
draw it. You can draw it as a plane graph. Okay,
Mhm.
you can draw
No,
the
ma'am.
plane part of this one. So I think it should be planar. In the definition, it should be planar graph. Okay, for a plane graph, it have to be a planar graph. Why they have mentioned here as a plane? Because the number of number of regions, it is, we can draw it like this. Okay, now good.
Yes, ma'am. So, ma'am, my question is, when we will be counting the number of faces in K star graph, uh, then we have to make it plane graph, right? So, drawing like this will be better, or drawing the previous one how you did?
So drawing this one will be better
Okay, ma'am.
because number of regions are decided by plane part, right?
Yes, ma'am.
So that's good. You pointed out this point. Okay. Yeah. What about K3? Sorry, P3. K3 is done. K3 is
Ma'am,
done.
two loop in single word.
Two loop will be and with the single vertex. So here three number of faces will be there. Okay. So one unbounded, one two bounded, and two edges will be there. Two edges. These can form a loop as well, right? P3, P4. In case of P4, there will be 3
3
loop and one vertex. In any tree, if we have of order n, how many vertices? If T is a tree of order n, in this one, n we have number of vertices, m denotes the, or you can just say n minus 1, m will be n minus 1 over here. Okay, and number of faces. Tell me number of faces. Number of faces
1
for tree. 1, because it is
open.
not having any cycle. Yeah, it is
Okay.
open. Uh, Corresponding to this tree, what about T star? T star.
It will have n minus 1 loops.
Yes. So one vertex corresponding to this one and n minus 1 loops and n number of faces out of that n minus 1 are bounded and 1 is unbounded, like this. So this is also a tree Pn and Pn star will be this one. Clear?
Yes.
Okay, try to draw C and C5. Yes, C4. C4 star. What is the size? It will be 4. Clear? And how many vertices will be there?
2, 1,
2.
2.
And as is
4.
4. In case of Cn, can you generalize it?
N edges and 2 vertices.
Edges.
Multiple edges.
2 vertices and n edges. So this is your Cn star. And Pn star is this one. N number of, n number of region only and n minus 1 edges. Loops, you can just say. Yeah, this is your C3. This is your Cn. Okay, for Kn, K2, again the same thing. Yeah, in the plane graph, faces are region. Okay, edges are the portion where faces meet. You can just see two faces meet. Okay, and the vertices where edges meet. Clear? Yeah, dual of K4. Yeah, here in some books you might find E is the number of edges. Okay, so don't get confused. M is same as E. We'll discuss a formula, that is Euler's formula. In that also it is denoted by E. Okay, so this is your K4. So you can draw over here. This is from here. Okay. Yeah. Dual of Q3. Dual of Q3. Dual of Q3. Q3 is your plane graph, planar graph. That's why we are able to draw it as a plane, right? So this is your plane part of Q3, cube in 3 dimensions, and its dual will be how many region?
6.
6 region, 5 this one, and if you draw in 3 dimensions, these 6 region are transferred it to faces, right? These become faces. This is your, this face is your U face, and the rear face will be X, right? That one. Clear? That face, that side will be X. Clear? So in the 3-dimension, these faces, and in 2-dimension, these are the regions. Yeah. Number of faces 6. That's why 6 number of vertices over here. Now, corresponding to X and Z, X and Y, this one, X and V, and X and W. Means X is adjacent to all these 4. Will X be adjacent with this U vertex? Will there be adjacency in U and X? Tell me. No.
No.
Because there is no edge intersecting at this, right? These two faces are not meeting, right? Here. So this X is adjacent to all these. Clear? And here Y and Z, you have this edge. That's why Y and Z. This one. V and Y. And U will be also adjacent to all these. Okay? You will be also adjacent to
So
all these, not with X. Okay? This is adjacent, this is adjacent. You can redraw this as a plane part. And this one is your graph isomorphic to K22, tripartite graph. Okay? Now try to draw, I have drawn over here. Dual of this graph. How many regions? 2 regions. So 2 vertices will be there. These 2. Okay. Corresponding to this edge, we have one loop. Or you can just say, if you notice over here, any edge that is present on cycle, all the edges present on cycle become the loop. Become the multi edges, and which is a cut edge or brace that become your loop. Okay, any brace, every brace become your loop, and all the edges of cycle become your multi edges. Clear?
Yes, ma'am.
So that's it for today. This one again the same thing. I'll start with this. Okay, in next class.
Thank you, ma'am.